Okay. Hi everybody, this is the Hydrate Lab. Alright, hang on, this crucible has a hydrate in it. Empty, can you tell me it again?
10.58.
Before we put the hydrate into the crucible weighed 10.58 grams. Write that down, 10.58. Now the crucible has a scoop of hydrate. The hydrate, if you can see that, it's copper sulfate, CuSO4, with some water molecules in there. We don't know how many, that's the point of the lab. Weighs 16.11 grams, 16.11. Write that down. Thanks, Mike. All right, this group with the copper sulfate, can you see that? Oh, there's a glare. It's in there. They're heating it, and why are we heating it, guys?
To remove the water.
Right, we are removing the water. The water is going to evaporate, so the little water molecules in there will go out of the crucible, leaving behind just the copper sulfate compound. And when it's lacking water, we call it an anhydrate because it's dehydrated. Oh, now you can see the copper sulfate. All right, they're going to heat for about 5 minutes. We'll be back. All right, while the hydrate is heating, I'm going to show you the formula of the compound. If you look up there, the blue compound is called copper sulfate, so that's the one that we're looking at. We are trying to figure out how many water molecules are associated with every one copper sulfate molecule in that particular compound. So if you notice the copper sulfate dot question mark water, that's the whole formula of the hydrate. We're removing the water right now by heating it, and what will be left behind is just the CuSO4, and when it's by itself, we call it an anhydrate. So to give you a better idea of what it looks like on a molecular level, if we could see all the little molecules, the copper sulfate, the compound, is actually a larger molecule than the water. So that is why there are more water molecules drawn there, and we're trying to find out what the ratio is for the anhydrate to the water. So in the end, we'll get a mole ratio of 1 to something, and that something number will be the question mark for the water. All right, here's the hydrate after heating. You can see that it's completely white in color, whereas it used to be blue. And we're going to go weigh it in just a second. All right, we're weighing our anhydrate to see what its final mass might be. It was 11 last time?
Yeah.
Okay, so that's perfect. All right, our final mass of the anhydrate is 14.09. So write that down, 14.09. All right, just so there's no confusion, you should have for your data on the back of the lab sheet, your hydrate is the copper sulfate dot question mark water. So you are trying to find out that question mark through your calculations. The mass of your crucible is 10.58 grams. The crucible with the hydrate in it at the beginning of the lab before heating it was 16.11 grams. After heating and evaporating the water out, the crucible with the anhydrate weighed 14.09 grams. So you're going to use those amounts of mass to calculate the masses of, obviously without the crucible involved, for number 1. Number 2 is a percent composition problem, where you're calculating the percent of the copper sulfate in the whole hydrate and the percent of water in the hydrate. And then numbers 3, 4, and 5 kind of all go together. Just like you did your empirical formula, you're going to do a grams to mole conversion for the anhydrate. Keep in mind the anhydrate is copper sulfate, CuSO4, and obviously water is H2O. So when you're calculating grams to moles, you're using molar masses of those two compounds. And in the end, you're going to find the whole number mole ratio by dividing by the smaller mole number that you get for your answers in number 3. And that will give you the formula of the hydrate. You should get a 1 to some number ratio, 1 to some whole number. And that number will be representing the water molecules in your hydrate. If you have any questions, post them on Schoology.